All right, let's talk about building smarter AI. Most of the time, we think the answer is just more data, right? Just throw more stuff at the model. But today, we're going to flip that script. We're not just feeding a model, we're going to engineer a system that actively constructs its own knowledge. Think about that for a second. We're talking about building a genuine, verifiable source of truth from the ground up.
So here's how we're going to break this down. First, we'll tackle the big problem, passive AI. Then we'll get into the really cool part, automated expert elicitation. After that, we'll see how to actually assemble the source of truth. And finally, we'll connect it all with the bridge to reasoning. Let's get into it.
And this quote right here, it really nails the core idea. You see those two phrases? Passive data pipelines versus active knowledge acquisition? That's the whole game. This isn't just a minor tweak or some small upgrade. It's a totally different way of thinking about how we build specialized AI. The kind of AI you can actually trust to be an expert.
Okay, let's dive into our first section, the problem with passive AI. I mean, retrieval-augmented generation, or RAG as we all know it, is everywhere. But what's the actual fundamental challenge we're facing with the standard approach?
Okay, so picture this. Standard RAG, it's like plugging your AI directly into a hurricane of noise, a chaotic cloud of completely disconnected data. You know, the internet. And what happens? The AI gets a really shallow, surface-level understanding of things. But even worse, and this is the part that keeps engineers up at night, it starts to hallucinate. And it does it with so much confidence. It just confidently makes stuff up because, to it, credible signal and random noise look exactly the same.
So if that's the problem, what's the solution? How do we fix it? Well, that brings us right to Section 2, automated expert elicitation. This is where the real engineering begins. It's a process designed specifically to slice through all that web-scale noise and lock onto something real, validated human expertise.
So how does it work? It's a pretty slick, automated three-step process. First, the system scans the entire web looking for potential expert candidates. Then, and this is key, it analyzes their digital footprint. It's hunting for something we call data density. Basically, is there enough high-quality structured thinking there to actually pull rules from? And finally, out of that enormous pool of candidates, it gets super selective. It validates a tiny, tiny fraction. For this project, it boiled down to just 6 expert nodes.
And check this out. This is an actual output from the system. Notice it's not just a name. It gives you the reason for the validation. It pinpointed Mark Benke, a research chemist, not because he has a ton of followers or something, but because his writing contains molecular/material evaluation logic. That's the goal we're mining for, that deep, causal, how things work knowledge.
All right, so we've got our validated experts. The signal has been separated from the noise. Now for the really crucial part, the core engineering task, assembling the source of truth. We're about to build a very special kind of blueprint for our AI. It's called the epistemic anchoring document, and we're going to construct it layer by deliberate layer.
Now this document, it's not just a data dump. It's a really elegant, highly structured artifact. It has 4 distinct layers, and each one has a job. You've got the expert roster, that's our proof of authority. Then you have the structured rule base, which is where we translate human intuition into cold, hard logic for the machine. Third, there's a narrative user guide, which explains the why behind the rules. And finally, a comprehensive glossary so the AI speaks the language of the domain with absolute precision.
Let's zoom in on that second layer, the rule base, because this is really the engine room of the whole operation. What we're doing here is taking what experts call tacit knowledge, you know, that stuff an expert just knows in their gut from years of experience, and we're making it explicit. We're turning it into machine-readable logic. Honestly, it's kind of like a super-powered modern take on classic knowledge engineering from back in the 90s.
So what does that look like in practice? Here's a perfect example, a real rule pulled directly from Mark Benke's work. A user asks for something in beast mode. A simple AI might just crank up the concentration. But this system? Nope. It knows better. The rule says if a user requests beast mode, then warn them, because materials like bergamot can actually distort and smell worse if you just blast the concentration. See? That's nuanced, causal logic. It's chemistry, not just keyword match.
And it's not just about these complex if-then rules. That fourth layer, the glossary, is absolutely critical for preventing simple but major errors. Take a word like silage. You and I, and definitely a generalist AI, would probably just think that means strong or long-lasting. But that's wrong. Our anchor document defines it with technical precision. It's the trail a perfume leaves behind. Getting that right prevents the AI from making all kinds of common vibe-based mistakes.
Okay, now I want to show you something that might look a little out of place. A hard number, roughly 1%. Now, in a field that seems so subjective, so artistic, like perfume, what on earth is a precise number like this doing here? Well, it serves an incredibly important purpose.
This is what we call a hard verification marker. It's a concrete, quantitative fact that acts like an anchor for the AI's understanding, holding it down in reality. That 1%? That's the approximate dose of aliphatic aldehydes in the Chanel No. 5 formula. A single data point like this anchors the AI's knowledge about an entire family of fragrances to a real-world, measurable value. It's not just relying on some vague marketing copy anymore.
And that brings us to the final, crucial piece of the puzzle, the bridge to reasoning. Look, we've just gone through this incredibly intensive engineering process. We've built this dense, validated source of truth. The big question is, now what? What do we do with it?
This is the payoff for all that hard work. You have to understand, the epistemic anchoring document isn't the end of the line. It's the foundation. It's the solid, engineered connection point to the next major component in the pipeline, a logical reasoning engine.
So, if there's one thing to take away, it's this. We have fundamentally shifted from basic information retrieval, just grabbing stuff from a sea of data, to active, deliberate knowledge construction. The AI is now anchored. It's grounded in verified expertise. It's finally ready to think, not just search.
So there you have it. We've engineered a source of truth, we've anchored our AI. But, solving one big problem always reveals the next one, doesn't it? And that leads us to the next great engineering challenge, and the question I want to leave you with today. Once an AI is truly anchored in truth, how does it actually learn to reason?